Welcome to Homework Lib.
Okay, so rest draw structures are the following. The first one is isobutyraldehyde. So the butyral is for butane, and it's gonna be a 4-carbon aldehyde. Next one is 4-hexanol. So you know hexane, 6 carbons, the Al ending in positive an aldehyde, and the En, the hex E in all, implies we have an alkene, and it's gonna be on carbon 4 because we couldn't have an aldehyde in the middle of a chain. So 1, 2, 3, 4. And we have an aldehyde right here. So 1, 2, 3, and 4. It's gonna be this way. And for C, we have diisopentyl ketone. So di is 2, and the isopentyl is going to be a 5-carbon chain. And this will be the ketone right there. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So an isopentyl group is just it's really this Y shape right here. It's characteristic of the isopentyl. And we have 5 carbons. It's going to be isopentyl. But this is characteristic of the iso group. This sort of Y shape. And then for D, we have 3-methyl cyclohexanone. So cyclo is a ring, hexane 6. And then carbon 3 as a methyl group. This would be carbon 3. 2, and then carbon 1 is we have the own ending, so there's a ketone on carbon 1. And the next one is 2,4-pentane dione. So drawing pentane first. And making this carbon 2, 4, and 3. And the own ending passes a ketone. So 1 here and here. And this is a case where you have to designate where the ketone is. If we just had the structure, this would just be a butadiene because it couldn't be on carbons 1 or 4. You could just say butadiene as opposed to 2, 3, butadiene. But with this structure, it could be 2, 3, pentadiene instead of 2, 4. So we have to use numbers in this case. And the next one is 4-bromo, 3-heptanone. So heptane is 7. The one is the ketone. It's on carbon 3. Carbon 4 is a bromine. Next one is gamma bromo capraldehyde. So another name for capraldehyde is actually hexanol. One, two, three, four, five, 6. And we have a broma at the gamma carbon. So the one adjacent to the carbonyl is alpha. This is beta, and this is gamma. So it'll be right there. Next one is 2-ethyl cyclopentane carbaldehyde. So cyclopentane. is a 5-carbon ring. We have an ethyl on carbon 2. Actually, just drawing the aldehyde first. Just going to be a 1-carbon aldehyde for carbaldehyde. And 2 is an ethyl group. Next one is 4-methyl 5-oxohexanol. So the oxo prefix is actually a ketone because the aldehyde has priority over the ketone. And the parent chain is hexane or hexanol. So putting the aldehyde here in the beginning. 1, 2, 3, 4, 5, 6. And we have a methyl on carbon 4 and a ketone on carbon 5. 1, 2, 3, 4. And here's the ketone. For J, we have benzene 1,3-dicarbaldehyde, and benzene is an aromatic ring with alternating double and single bonds. Carbaldehyde is a 1-carbon aldehyde. This will be carbon 1, 2, and 3 right here. That's it. So I think the first thing you should do is identify the parent chain, whether it's pentane, hexane, or any other chain, and then gamma is used, or the Greek letters are used for the alkyl halides, like chlorine or bromine, and the oxo is for ketones. Isopentyl, or an iso group, is really just this Y shape right here.